In this video, we will explore object-oriented programming concepts. An object is a fundamental unit in object-oriented programming that encapsulates related state and behavior. It is an instance of a class representing a real-world entity in software design. Key benefits of objects. Modularity. It means an object source code can be written and maintained independently from other objects, ensuring flexibility and reuse across a system. Encapsulation. It is also called as information hiding. Objects expose functionality through methods while keeping internal implementation details hidden, enhancing security and maintainability. Code reusability. Developers can leverage existing objects written by others, reducing redundancy and allowing specialized components to be tested and reused efficiently. Pluggability and debugging is objects can be replaced or modified without disrupting the entire system. This mirrors real world problem solving. For example, if a bolt in a machine breaks, you replace the bolt, not the entire machine. Example: if employee is a class, then a person working in a company is an object of that class. What is class? A class is a blueprint or prototype from which objects are created. It defines state and behaviors that objects of that class will have. Example, let's consider the sample employee class. In this class, name and salary are attributes and work is behavior. The employee demo class creates two employee objects and invoke their respective methods. Inheritance. Different kinds of objects often have a certain amount in common with each other. Car and bike, for example, all share the characteristics of vehicle, yet each also defines additional features that make them different. Object-oriented programming allows classes to inherit the commonly used state and behavior from other classes. Let's break it down with a real-world example. Imagine you're designing a system for different types of vehicles. This class will contain common attributes and methods that all vehicles share. A car is a type of vehicle, meaning it inherits properties from the vehicle class. The keyword extends is used to indicate that car inherits from vehicle in Java. Similarly, a bike also inherits properties from vehicle. So, the key takeaways are car and bike inherit brand and wheels attributes and methods stop from vehicle. They extend functionality by adding their own unique attributes and behavior, which are door, honk, has gear, wheelie. This approach avoids code duplications and make the system easy to maintain. An interface in Java is a blueprint for classes that defines a contract they must follow. It specifies what a class should do, but not how to do it. Interfaces help achieve abstraction and multiple inheritance in Java. The animal interface defines a abstract method make sound. The dog and cat classes implement animal interface providing their own implementations of make sound. This design ensures flexibility since different animals can be introduced without modifying existing code. Just add a new class implementing animal. A package is a namespace for organizing classes and interfaces in a logical manner. Placing your code into packages makes large software objects easier to manage. Why use packages? Because it avoids naming conflicts between classes, provides access control, helps maintain clean project structure. Imagine you're building a library management. You can organize different functionalities into packages. Step 1. Declare a package. The first line, package library.books, declares the package name. Step 2. Using the package in another class. Now, another class can use book by importing it. The key notes are import library.books.book, make the book class accessible in library app. Without import, you would need to use full path. Types of packages. Built-in package provided by Java, Java Util. All these are examples of built-in packages. User-defined packages are created by developers. Example library.books, com.company.module, etc. Encapsulation is one of the core principles of object oriented programming, ensuring that sensitive data is hidden from direct access and can only be modified through controlled methods. Think of it as a protective shield around data in a class, allowing interactions only through defined access points. That is, using getters and setters. Consider a bank account. The balance should not be directly accessible or modifiable. Instead, customers interact with their balance through secure methods like deposit and withdrawal. The key takeaways are encapsulation hides sensitive data. Balance declared as private is not accessible outside the class. Balance is accessible by these methods deposit and withdraw by providing controlled access. It also prevents accidental modifications and maintains security.